Hey, Oren.
Hey Trevor, how you doing?
Not too bad. How are you doing today?
Very well, thank you. So we started to get some people joining in, and I thought we should start everything by having you introduce yourself.
Sure,
Yeah.
I can do that. Hey, everybody. My name is Trevor. I'm the Chief Technology Officer at Rakuten Kobo. Usually just means that it's my fault when something goes wrong, whether it's an incident, project delay, or a poor technology choice. It's kind of on me. But I have an amazing team, teaches me a lot of things, and punches above their weight, and makes up for some of my mistakes as well too. But yeah, that's me.
Okay. And what is Rakuten Kobo or Kobo Rakuten? I keep getting them confused.
Yeah, Rakuten Kobo, or just Kobo as I call it, is an ebook retailer. So we bring books from publishers and independent authors to millions of readers around the world. We have apps and our own hardware e-reader devices. Pretty complex catalog management system with
Mhm.
millions of titles available, e-commerce system, and then various systems to support all those fleet of devices and apps that are out there. It's not a small domain, but it's
Uh,
certainly one that's it's nice because it's relatable. People pick up a book and they can use it and stuff. So
I was actually just about to ask about the complexity of the domain because I'm assuming that it's not about, oh, I have a list of files in FTP that I can just send over to a device and just thinking about, I'm thinking about, I have a book. You cannot sell that in Italy because there is different geofencing involved and all sorts of stuff like that. What is the most, call it, illogical business rule that you ever found? Can you tell us?
um, I think there's you're right. The domain is massive. When I first joined Kobo about 10 years ago, I was worried about getting pigeonholed into the one area. But the domain is so broad, from the publishing industry to the self-publishing world, where we're trying to bring independent authors forward. But I think the one rule that sort of caught me or set me for a loop, it, we push a lot on different business models, like just general e-commerce, but also subscription models and
Mhm.
things like that. But when it comes down to it, I think things like the geo rights, like this book's available here, but this book's not available here, or this book is called this in this region, but it's called this in this region, or regions with fixed price rules. Like, for example, in France or Germany, the publishers set the prices, not the retailer, because there's a cultural value to books,
Oh
and
my God.
they shouldn't be devalued. So there's a
Sorry,
lot of that in it.
we had, so I'm in Israel and we had a, a few years where the physical bookstores basically went crazy and you can buy three for 100. To translate that to US dollars, that's about 3 books for $20 or so. And the government passed a law that you cannot sell a book at a discount. Now, those were cases where the publisher set a price for the store and the store sold at a loss because they wanted to get more customers. And the end result was that there was this huge drop in people reading things. And sorry, I love books, and this has been a, a, a very predictable behavior on everyone parts. Yeah. Uh, by the way, you mentioned geographic location. One of the things that I found extremely surprising was that there are translations of Harry Potter to English. So you have the UK version and the US version that are not the same.
Yeah.
Uh, okay, so the reason that we're here is to talk about RavenDB, and I would tell us, how did you find RavenDB? How did you run into that?
We've actually been following it for a lot of years, and I distinctly remember when I first joined Kobo, probably 9 years ago. I had a conversation with you and my manager at the time, um, and you were reviewing our Couchbase setup. And I remember the single quote from you at that time was, you guys are doing something wrong, which yes, we were doing half the things wrong, but Couchbase was also a big part of that as well too. But Kobo's journey from startup to wanting to scale past relational databases, we took the natural route, which was memcached at the time. It was, let's add some caching in front of the SQL, which led us into Couchbase. And we at one point thought that we could start replacing some of our system of record, which was in relational databases, with Couchbase as a system of record. We never could quite gain the confidence in Couchbase to do that. So Couchbase ended up being more of just a durable cache for a lot of our systems rather than that. But over the years, and quite a lot of years, document databases came a generation further past where Couchbase was. We had RavenDB, we had MongoDB, we had a proliferation of those databases. But we kept an eye on RavenDB and MongoDB as kind of alternatives. And then there just came a point in time where we had a service that was sitting out in the cloud. And for what it was costing us a lot of money in storage and compute and things like that. So we thought we could do a better job of bringing it in-house. That was our annotations database that we'll talk about.
What is annotations?
So annotations, in a book that you're reading, if you put a bookmark, or if you highlight a piece of text, or if you take a note about a piece of text, or even in our new users, you can write on top of the ebook. Those are annotations for a book. And we store those for all the users that are out there and synchronize them across that user's devices.
Okay, so that's, but just based on your scale and needs, that's quite a lot of information.
It is. It's our biggest database on RavenDB today. Probably getting close to about a billion documents that we have in there. So.
Okay, so you were talking about bringing things in-house, and what were your criteria? What were you trying to achieve?
Well, we wanted to be more resilient in performance. Definitely, the service that was out in the cloud through some of its design and implementation wasn't that reliable. We wanted it to be performant. We want to increase the performance of that because we find that slow services for synchronizing user data across these devices results in poor battery time for our devices, which is very important to us, but also poor user perceived performance when they're going across devices. And then just developer experience. Our very big push for me is just productivity of development teams, and that has many facets. It's a lot on the interface of the technology and infrastructure with the development process, but it's also and how much planning do we have to do from a perspective of how many interruptions the team has.
Can you explain what you mean by that? What do you mean by interruptions to the team?
Sure. There's a number of things in production that we've experienced over the years. One is our desire to upgrade something, and the easier it is to upgrade something, the less work it is on development and operations team to plan that. Just generally, if something goes wrong, we have a small enough team that's all hands on deck type thing, and that disrupts sprints. It disrupts people's weekends, and the more interruptions like that we have, even for a secondary service, it's important for us for the customer experience. So that just disrupts the normal flow of things.
Okay. So at this point, you have a problem. You decide to bring things in-house. So you know that you want to do better than what you currently have. What are you looking for? What was the criteria by which you selected things?
So we knew we needed resilience as a first step. We knew we needed performance as a second thing, and we knew we needed developer experience as a third thing. But our approach to that was we write those things down, we write our assumptions or our goals of what we want them to be, and then we take an approach of what I would call exploratory testing. That's validating those assumptions, deeply observing the black box that the technology is and saying, that doesn't seem right. Let's dig into that. Or okay, that worked well. Let's try and break it. Let's understand it a little bit deeper and see if we can push it to its limits a little bit more, so that we're not surprised when things like that do happen in real life. So the exploratory testing approach of bringing those technologies in was pretty important to us.
One of the things that I found, there is this joke that in war, the general would always fight the last war.
Yeah.
So for World War II, then everyone thought, oh, we are digging trenches, and everyone was surprised by the tank and stuff like that. What I found when we are talking about those sort of evaluations, one of the things that people do is they'll base their exploration on what was painful. So I can tell you that my mother at one point said, I want a new house, and the sole criteria she gave, there can be no stairs. I don't care what size, I don't care where, no stairs. That's the only thing that I care about. So what were the things that were important to you, and what can you share about why they matter?
So I think not a great experience. Like the thing that we didn't like was we were scared of touching some of our clusters. We were scared of touching a node in the cluster. We were scared of increasing the capacity of the cluster by adding more nodes. We didn't like upgrading the version of the software because inevitably that meant a lot of planning and a lot of downtime for us on those services. And that's something that pushed us away from some of the best practices that we'd normally do. So that sort of resilience of being able to take a node out, put a node back in, add more nodes, run a mixed version cluster where we could upgrade one node to the new version without impacting any downtime, or even upgrading the other nodes at the same time. Those kind of things were important, as those kind of operations should go smoothly, and should, by doing that, reduce a lot of load and fear of upgrades on our team. So I think that was probably our overriding criteria. And then performance, obviously we want to get better for our customers, so performance was the secondary criteria on that. Okay. The third criteria, again, just on the developer experience, it's developers aren't perfect. We've got a great team, they're very knowledgeable, but we have new members joining all the time. And that sort of onboarding experience and ramp-up experience is kind of important. And the design of the technology to lead you down the right path, the pit of success or whatever, is kind of important to me as well too.
So okay, so we have your criteria, we know what you want. What did you look at, and what were the results of your findings?
Sure. So we had an existing service sitting out in the cloud, table storage behind it, applications against the different data sources. So same application, 3 different data sources, same data, same scale of data behind it. And we tried to basically run exploratory testing on it, which included load tests, performance tests, and destructive tests where we would underload, yank a node out of the cluster and turn things off and delete the disks from the server and things like that, just to see how these things behaved, which was incredible fun. I'll give it that. Just doing this was incredible fun. So
at one point when we designed the RavenDB cluster behavior, one of my dreams was to be able to run on Raspberry Pi and then set up a cluster of Raspberry Pi and then take a hammer to one of them while they are running and see what happens. Didn't actually end up doing that, but apparently if you just disconnect a network, that's good enough for most things. Or pull the SD card, which is actually worse. Yeah. So which databases do you evaluate?
We did Couchbase, RavenDB, and MongoDB.
Okay. And in terms of the experience setting up, can you explain to me what, because you're already familiar with Couchbase at this point, if I remember correctly, you were testing an updated version. Am I correct?
Sorry, I missed that. My connection was a bit unstable there.
Yeah, you sometimes freeze for me as well. What I'm asking is, if I remember properly, you were looking at an updated version of Couchbase compared to what you were running in production to see if anything changed. So I'm not going to touch on that because we'll talk about Couchbase more down the line, but you looked at Mongo, and what was the experience in setting up, running, performance of the whole thing?
So our experience, just in general high terms, was both Mongo and RavenDB vastly outperformed Couchbase in resilience and performance and resource usage as well. We can get into a little bit of detail of that later. So when it came down to it, it was a very close race between RavenDB and MongoDB. I think what clinched us, if we want to get into raw numbers, I think Mongo and a few types of queries was slightly faster than RavenDB, a few optimizations. Its resource usage was much greater than RavenDB. There's no way we could get it run on a low spec machine or even a Raspberry Pi. And the developer experience, it just wasn't there. It wasn't safe by default. It wasn't leading in. And then just the tooling around the operational side of it, we found with Mongo, we had to join a bunch of different, might be considered flexible, but it's also just an extra overhead to get up and running. And then just the quality of support of working with your team, the approachability of RavenDB in terms of setting things up for a ethereal environment or local environment, the test driver effort that goes into sort of the unit testing story around it, just seemed much more complete than MongoDB did. So if all things are equal on performance and resilience, then the decider was the experience, and it was much better.
So let's talk for a second about resilience. So let's talk about resilience for a second, and let's see what we're talking about in terms of what is this destructive testing that you did, and what were the results, and what are the things that you got burned from that says, I can't believe that this worked, or I can't believe that I can do that?
Yeah, so we had fun with the destructive testing, like force powering off a node or pulling the network connection on the node. But that just resembles a pretty common operation that we want to do. If we want to upgrade the cluster to a new version of software, we're going to pull a node out. If we want to increase the capacity, like the disk space on a node or fails, and we want to put another node in, that's pulling a node out. So that changing of the cluster topology was very important to us. So what we did was under load, we ran our load tests, we looked at the performance and throughput, and then we yanked a node out of the cluster. What we observed, Couchbase, because of its architecture of a distributed database, essentially went down, started giving a lot of errors as it tried to rebalance itself across the other nodes. So we had about 2 hours of degraded performance, increased errors because of Couchbase rebalancing itself at the time. RavenDB, we got 1 or 2 errors of writes, which is expected because writes transactions should fail in a thing like that. But then it continued on with no impact in performance. The master setup really worked there. On the MongoDB side, it was very similar to RavenDB, except there was a bit more of a delay switching over the master to one of the slaves because it's a sort of a primary secondary architecture instead of the master architecture that RavenDB has.
Okay. What was the test? So we actually, I'm actually going to show my screen in a second. And what happened was that we worked with you on those testings, and I did not believe your results. And the reason I don't believe your results is that I don't know if you remember or you're aware of that, but when we built RavenDB, one of the things that we did, I read the code base of CouchDB. And that's in Erlang, and I did not know Erlang. But I remember being impressed with the code, what it's doing, how it's approaching things, and I had that same expectation when it came to Couchbase. And then you came and says, oh, I have this amount of data, this amount of queries, and this is what I'm seeing, and here is the comparison to our solution. So we actually set out and built the exact same thing. Roughly from public data sources, we reproduce, and the script to do that, and the information is all publicly available. And the interesting is that we tested that on a 3-node cluster, and we try to push the 10 to 20,000 requests a second, which is very high load even for big ticket websites. That's 20 requests per second is 1.7 million requests per day. And do 10,000 requests per second. That's not matter I can do in my head, but that's a lot, lots of requested users. And the interesting thing was the impact. And I can show you, this is the table that we published from the paper, and the budget version, and let me go back for a second. Let's talk about what were your requirements. We mentioned a lot about resiliency and errors, but what were your SLAs, and how did you find this is acceptable, this is not acceptable?
Yeah, so on the performance side of things, we generally aim for a response from our application with a P95 of under 100 milliseconds. And to achieve that, the database needs to be much faster than that, within 100 milliseconds. With Couchbase, we were regularly seeing the database portion of that being well over 150, 200 milliseconds, just for document lookups, never mind complex queries. So from a raw response time, we just couldn't get that level of performance. And as the scale went up, more resources in the RavenDB cluster in terms of cores available and memory available. Its CPU usage was through the roof for a given moderate number of requests, whereas RavenDB was sitting less than 20% usage on the CPU. So we had performance, which was just raw, like a single request latency, and then we had the scale given the number of resources that we had. And Couchbase really didn't live up to expectations on those compared to what we're able to achieve with Raven and Mongo.
Given the amount of time that you were running Couchbase, and this is call it professional curiosity, document lookup is about the fastest thing that you could have. What do you know what Couchbase is doing that it is slow?
We didn't investigate it too much. It wasn't a network. The only thing I can speculate on that it would be serialization overheads or some kind of client overhead that'll be, but it doesn't explain the high CPU usage on the Couchbase cluster itself.
Yeah, I actually was running that, and when I think a lot of that is about the queries. And if you're querying, we did some simple queries to test that. And when I run it on our data set, the starts with query. Just to give some idea, the Couchbase version that we tested was 96 cores, 384 gigabyte cluster. So 3 servers of 32 cores and 128 gigabyte each, and the data size was just over 1 terabyte. And the queries that we were trying to run was something like, give me all of the document that has a particular prefix. And in your case, that would be something like, give me all of the highlights for, give me all of Oren's highlights books for Harry Potter, is a good example. Yep. And we tested that versus the same data set, but running on a Raspberry Pi. So 4 cores of ARM and 4 gigabyte of RAM, and the RavenDB with Raspberry Pi was actually faster. And I fairly certain that, and that was with indexing, obviously. So I don't know what's going on, but I was this tempted to dig in and send a patch, but then I realized that probably not a good idea on my part. Okay, so some numbers and you made a decision. What was it like to go from, okay, I can take a hammer to the server, see how it works, to, okay, now we have live production running on this?
So we took an opportunity not just with the technology, but to upgrade our operations practices and our operations recipes. We never really could get cross data center replication working with Couchbase. But as part of our commissioning of a production quality RavenDB cluster, one of our mandates was we need live replication to a different data center. We actually easily set that up. We've got our production cluster of 3 nodes, and then we've got our disaster recovery of 3 nodes, and they're across an ocean. And it works very seamlessly with the external replication. So that is a new capability that we're never able to achieve before, but you would think would be standard practice in any sort of database production organization. It's something we had for years with SQL, but never could get working correctly. So, you know, that design of that, then there was the security side. The RavenDB's use of certificates forced us to up our game in terms of PKI infrastructure and Let's Encrypt and things like that. So it was a bit of a burden, but it was a good burden. It was a good friction to help us get better at those practices. And now we're using that in other areas as well too. Our first application that went on it was the annotations, the biggest database that we had. And we had some fine tuning to do. We ran into some issues, but working with your team on those, you've seen my list of feature requests and bug reports, I'm sure. It's been fantastic. We wouldn't have been able to get that level of support or responsiveness from the other vendors, I believe. But the issues were never blockers. They were optimizations. They were quirks that we've sort of run into. So we've been very happy to move forward and always sort of keep up on the upgraded version of it. There's some feature requests that, you know, I think are good, but that they've come in time and they've certainly enhanced our experience as well too. So that sort of transition from test to production helped us up our game, helped us achieve things that we've never had before, but also really just give us an opportunity to work closely with your team, and that's been a really good thing for us anyway. So,
one of the things that if I'm talking to a customer, potential customers, and they ask me, why use RavenDB? One of the common answers that I talk to them is, okay, there is this modeling that you're much freer and a dynamic nature that you can, you don't have to run schema upgrades or monitor stuff like that. The high availability story out of the, all sorts of stuff like that. It's interesting. In many cases, I demonstrate features such as automatic indexes or MapReduce to show, hey, I tripled the size of the data, the query time remained flat, those sort of things. And I tell them what I think would be the most interesting things, interesting for them to hear. What do you think were the most impactful things from your perspective? Not just, oh, I pull a server and it's still working from the system.
I think operationally, the impact is the greatest, and it is on that resilience and the ability to do disaster recovery across an ocean easily, add and remove nodes. The operational story has certainly been the greatest improvement there, and it hasn't required a lot of reskilling to be able to do that. It works the way we would expect it to work. On the development side, we haven't really dive deep into complex queries. We haven't used the graph the stuff where we've used MapReduce and we've used output collections and those type of features. But areas that I'm kind of looking forward to on that is the subscription side. We're rewriting some of our workflows inside the services that we have to use RavenDB as the storage for in progress workflows that are asynchronous, and that being able to do that atomically within the entities being stored, as well as not have to install a whole queuing infrastructure for microservices, just we subscribe to changes on it, has been a great simplification of our infrastructure. And simplification of infrastructure is important to me when we're talking about microservices. It might be fine for a big monolith to have lots of queuing infrastructure and things like that, but the less infrastructure I actually have for my microservice, better. And if I have a database that's atomic, along with an ability to subscribe to asynchronous changes on that, and the ability to model the data with MapReduce, I have a lot of simplicity in my infrastructure compared to what I'd normally have to add under the skin for a microservice.
That's interesting. Can you explain? I assume that you're talking about the Outbox pattern, but I also think that some of the listeners may not be aware of what it is. Can you explain what is the problem that you're trying to solve?
Sure. Our databases, and we have about 20 or 30 of them running on RavenDB today. Our architecture is very much an application, typically a JVM or a .NET application, and they're using RavenDB as a private database. We're not using RavenDB with the same database serving multiple services. It's literally the private database, and we'll use an ETL or some other kind of subscription to talk to other applications. So when it comes to that pattern, inside that service, inside that application, RavenDB is the system of record. And if we want to communicate out to other services, we have to write the entity to RavenDB and then send an event sourcing message, which requires our application to have both a database and a queuing infrastructure like RabbitMQ or Kafka on the side. And it's not atomic. I can write the entity and then send the message or vice versa. Whereas to keep our services simple, what I prefer is our application only really talks to the database. It modifies an entity or maybe puts a new entity in. And then there's a listener in our application that's listening for those changes. And it might perform some enrichment of that data. It might broker that message out to other applications or something like that. But being able to keep our application simple, that it literally is only dealing with the domain model and updates to that domain model, simplifies our code quite a bit on that.
You mentioned the issue of atomicity. And one of the reasons RavenDB even exists was that I looked at NoSQL databases at the time, and none of them had transactions. And I don't want that. I really want transactions. So what was the factor of RavenDB having transaction in your decision-making process?
I think it's important for us that when we write the data, we have confidence in that data actually being written, as in persistent to disk. I'm not as much worried about the cross-cluster side of things. We rarely use cross-cluster transactions in anything, but the durability was important. And we didn't get that by default out of other databases. And I think what you describe is my experience with the first generation of document databases. And I'd put RavenDB up there as a third generation, in terms of solving some of those problems that were left to the side at the start.
So the next question that I have, because you actually have a really interesting perspective, because you also use Couchbase, which doesn't have transactions. Right. So what was the developer experience like with regards to transaction behavior atomicity when you actually needed to do that? Can you give me a scenario where that was an issue?
Yeah, so it goes back to the thought that we originally intended Couchbase to start taking over a system of record. In my mind, we can't have system of record unless it's durable to the disk. And yes, there might be a failure if I lose that node at that time, but hey, 2 minutes of lost data is not that important compared to losing something or telling the user I did something and it's not actually persistent. So that durability concern is a little bit more important. The other side of it, maybe just this is more opinionated than anything, I'm really not a fan of the layers and the stateless kind of repository patterns where it's a per request type of thing. I've seen unit of work, which would be embodied in the RavenDB session quite a bit, be much more useful for domain transactions and things like that. So being able to do the multiple document writes and committing them as part of the session has been very pleasant in the code to simplify things. Whereas before, our code took on the pattern of no transactions and everything hitting the database independently. Whereas now we can do things a lot more grouped and atomic and durable as part of it.
How is your business code looks like? So are you working with with smart entities that contain their own state? Are you having DTOs that are being manipulated?
This is a great debate between me, architects, and developers a lot. I think we started off with very anemic domain models, and now we're moving towards very rich domain models that know that encapsulate the session and encapsulate their storage, and it becomes, in my opinion, a lot more readable way of doing it. Like if you take the annotations, for example, my first operation is to load a book from the database. Then I call book.annotations.add a new one or update one, and then I save the book. I don't have 3 services injected to my controller method that one loads it, one saves it, one does the domain logic and things like that. It's a very natural. All operations happen on the book aggregate route. But that's a debate with architects and developers.
I actually wonder how much that applies to toolings. I remember the great area of IOC containers and inject everything and all of that. And I could not read code without a tool like ReSharper. And I was very good with ReSharper to navigate code and work on things. And today, I find that I'm doing most of my working with the code in the GitHub pull request page and just looking at diff files. And that changed a lot of how I want to see code. Don't give me everything in one place. So I have to try to keep everything in my head. I don't have ReSharper in GitHub. Okay. Next question that I have.
Just on it, I've always been the give me the minimal editor that I can, because that will improve the code.
It's actually really interesting if you see the feedback loop of the code and the environment feeding off each other. And it's interesting to see. A great example is right now when we have the language servers, something like VS Code and stuff like that, where you can write a relatively small amount of code and you get a really rich experience. And then you start seeing languages and that take advantage of that. And then the quality that you have for a language on a platform is drastically different. It's quite amazing to see that going on. And you can see that with, I like learning new languages, or at least looking at new languages, and Zig and Odin and Hare and there's quite a Rust benefit a lot from this environment. But I wonder also how much that environment also affects the development. Oh, this is hard to do, or this is easy to do, therefore we'll do that. Yeah. If we're on that topic, what do you think were the design changes that were introduced into the environment because of RavenDB, because of the things that you could do or were hard to do?
I think apart from what I mentioned there at the start about unit of work versus anemic domain models, I think that was a very good trigger for a positive change. The other one is the RavenDB test driver, the ability to embed basically a full server in unit tests, and how that's spin up very fast. And this is a controversial design direction in our organization, but I'm pushing it, is this idea of a full stack unit test. It's a test. Unit tests to me should be running fast, running repeatable, and give you good feedback on what fails. It doesn't mean it shouldn't talk to a database. A unit test can absolutely talk to a database as long as it's fast, repeatable, and tells you what goes wrong very quick. So we started down this idea of, RavenDB test driver as a real live database behind our unit tests, not mocking out the database, but actually running the real engine behind it. And what that does is there's less mocking available. We don't have to mock RavenDB, which is a complex thing to mock, or even SQL or anything like that. We use the actual real thing. It allows us to catch bugs earlier, serialization issues with JSON, or how do you unit test something that relies on an index in RavenDB and stuff like that. And then also just the quality of feedback that we get from the error messages and stuff like that help us detect and fix these problems earlier in our development cycle. So I would be a big proponent of, that embedded RavenDB, the test driver side of things, really changing the effectiveness and quality of the unit test cycle, which is great because you get feedback on things that are going wrong much earlier in your cycle before taking it to stage or production.
How are you using WaitForUserToContinueTheTest?
It's interesting. We've done a few things around that where when we're debugging a unit test and we can't figure out what's going on. When we're in the debug mode, we'll call the method to show the studio for that embedded instance.
From the expression evaluator?
Yeah, from the expression evaluator. And up pops the browser window with the full Raven Studio in there, and we're able to see step by step through the unit test what's actually going into the database and what it's doing. So it provides us with a much greater level of, just on my local machine, that ability to debug and iterate faster.
Okay. So when did you actually put RavenDB in production? That was 2-3 years ago?
Yeah, I think it was around towards the end of 2018, start of 2019 when we started. Yeah.
Sorry, I'm still at the point that this is now 2020 or something like that.
Exactly. The last 2 years have disappeared from my memory. I'm pretty sure.
So it's been 3-4 years now. Dear God. So what was so you started with the annotations and then it grew from there. What was it like to introduce the database to other projects, to other teams, other people who are not familiar with that?
I'll tell you one thing. A big part of technology adoption is how good the technology is and how approachable it is. That's a big part of it. But it's still a mammoth task to get people curious about it, trained up on it, experience it to the level of depth that we experienced it when we did the testing, the exploratory testing. So there's a lot of evangelism in the organization. The help that we got from your team was great. Like, the book is a good source, the documents are a good source, but I think two other sources that have been really helpful, the training webinars that your team done has allowed us to hit a lot of developers at a fairly deep level pretty fast. And then also just having the source code available. Like there's a lot of us that will just dig into, oh, this is how it works under the skin, or things like that. It's pretty good fun. We may not understand the full context of it, but at least we know what's going on, what's being worked on, like that. I think what we've done in terms of expanding the usage, it started with annotations, which is a large database, real-time user requests. That's one type of use case. We've added other use cases too, like shopping cart, which is a transient type of data that sticks around for a couple of days and then automatically disappears if the user abandons their cart. And then we've got into sort of batch processing side of things. And we've learned a little bit about, okay, well, it's maybe not ideal to mix these type of use cases on the same node. We can mix them in the same cluster, but maybe not in the same node. And we've sort of structured our environments around, here's the cluster does batch stuff, here's the cluster does transient real-time user requests where latency is really important, and here's the one that stores user durable data for long periods of time. So we've kind of structured our operations and set up around that. On the development side, it's been a little bit of evangelism, showing them the capabilities, and then just continuous review and learning and pointing out, hey, I see you did the index like this. If you designed it like this, it would be even better and stuff. So that I find often in development, the optimization cycle is often forgotten about. And with RavenDB, as good as it is out of the box, I find that you kind of need somebody to still be that DBA role, the one pushing for optimizations. Mm-hmm. This could be better than it is today. And I think that role is important no matter what database technology you kind of have.
What's the impact that you're seeing from that? We tell you every DBA that I ever found had the story of this critical application where it was very, very slow and they came, introduced an index and it was like, bam, everything is working. Yeah. What was your experience of, okay, here is someone who is not that familiar with RavenDB and they built something and now let's do that on the idiomatic way or the proper way to do that, and what was the impact there?
Yeah, I think a modern DBA needs to be a lot more full stack. It's not just about adding the index, it's about understanding the domain, about making the choice between natural document IDs rather than auto-generated document IDs to allow you to access without index, to know what the working set of the database actually is and how much RAM is important, to just the level like taking change vectors and making them etags out in the public HTTP API, things like that. A modern DBA needs to be much more full stack. But the impact of that is we're no longer just stuck with the first initial implementation. Our first initial implementation has shrunk in terms of the amount of work it takes to do because of document databases, and that leaves time for the optimization phases. Okay. Whereas before, we'd spend all our time just doing it and doing the mappings to the ORM and things like that, and we'd never have the time to come back and optimize. Mm-hmm. I think that's a big impact.
Okay, and when you do that, when you have this opportunity to go back and do this properly, because now you have the capacity to do that, what do you find are the most common changes that you do?
I think it first starts with, well, now that we've done it, we understand the domain a bit better. We understand that combined with some metrics, like what is the most voluminous API call that we have? What's the one that is most impactful to the UI? You get a better sense of where your optimizations should be put, sort of that whole premature optimization problem. And I think that's good. And then it comes down to, okay, what are we optimizing for? Are we optimizing for latency? Are we optimizing for data storage space? Like our annotations database is massive. And unfortunately, a lot of the keys in there are goods. And if I store goods as a normal formatting of it, it takes 30% more space than if I store them as base 64 encoded. So, little minor things like that pop up here and there, but it's a good conversation and a good cycle to actually be in to do that. And then you carry forward those learnings to your initial implementation of the next database and the next database and stuff.
Because you're running on RavenDB for several years now, you had a chance to do multiple deployments. And I'm interested not just in, okay, force them to production. What is like, okay, I have a feature, I need to change something in the database. I have to make, maybe there is a feature that changed, or those sort of things. What do you think are the impact of using RavenDB versus using Couchbase or a relational database for doing that?
I think back to the architecture side, there's this misnomer that document databases are schemaless. Well, they're schema later. The schema that matters at query time, not write time. And upgrades and schema changes are important to keep track of, especially if you do that. But the tool set that we've seen for RavenDB be able to do patches, being able to schedule and run those sort of bulk updates and things like that has been very useful in managing that. But to be honest, most of our stuff, we're able to run side-by-side versions, or we're able to incrementally add things, or add them in a forwards compatible and a backwards compatible way. Like the document database allows us to have a document with a section for key value pairs that aren't understood by our application today, but are stored and retrieved, but then promoted to proper properties in the future that we do validate and stuff. So that flexibility without a performance impact has been hugely important.
Here's a question. There is a feature in the RavenDB client where if it finds a property that is not in the document, that is not on the entity, it would round trip that seamlessly. And that feature is meant for multi-version deployments. We have version A and version B, and version B has a property, and version A would still be able to read and write, just ignore that additional property. Are you using that feature, or are you explicitly using a property bag on the entity?
I didn't know about that feature, but we
Okay.
we are explicitly using the property bag / dynamic objects for when we have that forward compatibility side of thing.
Okay. Okay. Here's let's talk about concrete stuff. Can you tell us about the technical aspects? What are you doing in terms of you mentioned etags and change vector. So you have some design decision that goes all the way from the device at the hand of the users all the way to the database. How does it work? What was the impact on your system? Those sort of things.
So taking the etag example, it's one of those features that allow us to optimize conditional gets. The typical HTTP API with the if match header, if not match header, it allows us to expose an API to our clients that has etags for conditional gets, that sort of optimization. And it allows us to use the etags for conditional updates as well, so that optimistic concurrency all the way to the client as well. We happen to have that all the way to the database as well. It's not an application level thing where we're still creating the whole document from the database. The support you added recently for those bulk conditional gets has helped us in that matter, where we get a 304 from RavenDB, we pass that 304 back to the client.
And for the people who aren't aware of what this means, can you give some context? What is 304? Why does it matter?
Sure. Basically, on some of our APIs, we will do a query to see if something's changed. So we have a device that has a view of the world in terms of its annotation data, and we have another device that has a view of its world in the annotation data. Every night or every periodic type of thing, that device will say, hey, has something changed? And if something has changed, the normal way would be to bring that whole thing back. And if something hasn't changed, we'll just return basically an empty body with the HTTP 304. The 304 is not just on that one request. The 304 will prevent the client from issuing multiple other requests to synchronize other entities and things. So it's important to us from a little bit of latency, because we don't have to move all those requests, but also load shedding. We don't incur requests that don't need to be made. And when you're dealing with millions of clients out there, load shedding is a very important aspect of that.
You also mentioned something about battery life. This is also something that you worry about.
Yeah, our devices, our e-readers, they're not like your phone. They don't need charged every day. We aim for weeks of battery life before having to charge it. And we do that not because there's some super efficient electronics in it. It's literally the device is off 99% of the time because the screen stays stable on it. So any Wi-Fi access, any request that keeps the CPU on, that keeps the Wi-Fi radio on, drains the battery more than you'd notice on a device that you charge every day. Because the battery capacities aren't that much different. We have a smaller battery in our devices. So every single second that we can shave off synchronization every night extends that battery life quite significantly. It's a much different type of thing than your normal cell phone type of battery where you're used to charging every day. But I would imagine that would also be important in an IoT type of situation as well.
Let's talk about retailers have Black Fridays. Do you have? I assume that you have something very similar, or probably also Black Friday. What is the experience like behind the scenes when something like that happens?
Yeah, we do have spikes. Over the years, those spikes have sort of flattened out, and the level has grown. Actually, Mother's Day is one of our big spikes because people buy books for their mothers.
Okay.
And the lead up to summer is generally higher load because people buy books before they go on vacation and then read those books on vacation. So it's a little bit different than the typical retailers. But I'd say our seasonality or seasonal spikes are usually pretty big within a month. Like there's a sale per month, or there's a sale in specific geo, or there's a need to that. But that's on the sales and the e-commerce side, and generally those kind of loads are easily handled. Where we have the bigger load is we have millions of devices out there, and they all synchronize at nighttime to pull down their latest stuff. So we have a daily spike that's order of magnitude more than what we have. And running that in the cloud when it's a daily spike could be very expensive because we're not able to shut it down for most of the year and run it up in the Black Friday type of time frame. So that's why we went on premise for RavenDB and this kind of load. So there are some things lend itself to the cloud where we do have the once a year type of spikes, but most of our stuff is, raising the level of a daily type of thing quite a lot.
That also leads to an interesting consideration. It's typical that, I can just throw resources and auto scaling and things like that on the cloud, and it's easy to say, even if I have a daily a daily spike, and I can just increase the capacity, but increasing the capacity even on the cloud where you can just push a button, and even aside the cost factors, is not free from the issue of complexity. The other side, if you're running on premise, then you had typically a much harder time changing capacity, which means that from our perspective, at night times, you might have this nightly spike of 10, 20 times higher load than the usual. And how do you look at that and make sense of this is okay, this is not okay, I have to be worried about that?
Yeah, I think there's two factors on it. It's really hard to scale anywhere if your resource requirements are high in the first place. So in the Couchbase case, for example, where it used so many resources and very little headroom of CPU capacity, like it was during normal load using 80% of its CPU, it's very hard to scale that because you have to add so many more resources to it. But if you're efficient in the first place, using 20, 40% of CPU under normal circumstances, and performance degrades in a predictable way, like it's because of I/O. So if your writes are infrequent compared to your reads, then you can take that into account into how you scale. So I think RavenDB's efficient user resources is a very big factor in ability to scale because it's easier to add small amounts of resources in increments than to try and add a whole big new server. We run RavenDB inside Linux virtual machines on VMware. We use local NVMe for low latency applications, and we use ASAN, pure storage, for more of the bulk type of things, like the node that's running backups or external replication, or if it's on the bulk rather than real-time request things. So we have an ability to do that, but if we need to spin up another node, it's another VM for us on a different host. It's not a whole new physical server that we're putting in with complex I/O.
Yeah. The typical answer that I get is, oh, sure, we'll get you a new server. It's 6 to 8 weeks to order that from the, yeah, that doesn't work for me. I have this now. What would be your process for, hey, I don't know, there is Harry Potter 9 coming out, and we have 12 hours to till it hits the website. What would your response to something like that be?
Um, First, on an architecture perspective, we're going to look at the hotspots and make sure that we can scale those. Certainly, RavenDB's in one of those hotspots with shopping cart, for example, because it's much more frequent than the actual purchasing activity itself. So that the frequency of access. The second thing is just overall failing gracefully is really important. If, for example, on the item page for that Harry Potter book, there's the ratings and reviews. We should still be able to show that page if ratings and reviews disappears from it. So that sort of modularity and reduced dependency map is really important inside our stuff. And by segregating the RavenDB databases and the master architecture, we have a much better chance of kind of building things that are fail safe or fail gracefully, and fall back under load or other reasons that they might do it.
You mentioned predictability and P99 as two metrics that you care about. Can you explain, and what are the things that you see?
Yeah, we did a lot of this during exploratory testing where we wanted to push things past what we had planned for, run many more requests per second that we could, figure out where the bottlenecks were, we ultimately it's a type of failure testing. And where things, in my experience with performance sensitive stuff, things go nice and smooth, and then just fall off a cliff. They rarely go linearly bad. And you reach a saturation point, buffers fill up, or something gets saturated, and then just things blow up. There's no smooth failure when it comes to performance. So we wanted to push things and see where we had to scale. And we find with Couchbase, we had to scale Couchbase. We didn't have to scale our application at all. Our application was sitting idle most of the time, waiting on Couchbase under heavy load. With RavenDB, it's the opposite. We have to scale up our Kubernetes application that's handling those requests more than we have to scale the RavenDB side. So for us, it's about, when we're planning, where are the bottlenecks, where do we have to scale, and where's it easier to scale for us.
Okay. Let's talk about the RavenDB features that you use. You mentioned indexing, documents, and subscriptions. What about features such as attachments or ETL?
Yeah, so separate into development or application side and operation side. On the development side, we use the general document lookups, we use map reduce indexes, we use other indexes, so fairly standard features. We use attachments in the case of the annotations. When you physically write using one of our note-taking devices, we store the bitmaps of those with the metadata that's about the location in the book that those things are. So we use those type of features. We use subscriptions in our workflow type of applications where we write a domain entity and some other worker picks up that change and processes it. And we use document expiry quite a bit for these transient kind of workflow use cases where we don't care about the document after 30 days, for example. On the operations side, we heavily use, obviously the clustering is core to us, but also we heavily use external replication to another RavenDB cluster, which is our disaster recovery environment. We use backups, both incremental and full backups quite a bit, preceding other environments, and we run the restoration process often just to make sure the backups work.
I was about to ask that.
Yeah. And it's quite interesting when people are surprised at how long it takes to restore backups sometimes, just copying the file back and stuff. But it's forced us that we have a tiered approach. Is we have high availability in the cluster. Our first tier of disaster recovery is our disaster recovery cluster that's in a different data center, and we can switch over to that in minutes. we treat backups as if something's really gone wrong and we're going to be down for a weekend away, type of idea. So there's that sort of tiered approach this is enabled for us.
The interesting here, especially if you go to the large databases, getting a 150 gigabyte backup just from cold storage to where you can actually do something can take hours, and then restoring that can take even more hours. I think there was recently with Altasian, with the one down for multiple weeks because of that issue. Not using RavenDB, by the way, but still, we all have to deal with the physical realities. So, what features of RavenDB you're planning to use but you're not using right now?
I think we're planning to use more of the subscription side of it. I know the potential support for ETLs to queuing systems is something that we're looking from an Outbox Pattern perspective. I think we have definitely used a lot of the Grafana monitoring side of it to build into our sort of operational side. We're looking to maybe get a little bit more into the Terraform and setting up of nodes to more automate the deployment and adding of nodes to a cluster and upgrading of the nodes. But there's a number of features that I've advocated for that I'd love to see us using. For example, open telemetry support that would allow us to, in our APM solution, to see timings and actual queries being run just magically. More photos. I saw you added the Postgres layer on top of that for sort of more plug-in DBA. I'm thinking more of we use InfluxDB for our time series monitoring type of stuff. If you supported the InfluxDB line protocol as an input, it might sort of ease a transition there for us as well too. So there's a number of things that we're using, but I think I would love to see us use a little bit more of that subscription stuff natively inside our microservices.
Okay. What I think you mentioned something about ETL, but I don't think that we talked about that. Are you doing cross-service data flow?
So we're doing cross-service data flow. So there is a RavenDB database that takes input from our devices, aggregates that in a MapReduce, and then spits that out to financial SQL databases for integration with downstream BI. We're using cross-data center ETL for disaster recovery. So that's taken from one cluster, putting it into another cluster continuously. And then there's a few ETLs that are fairly minor, just more experimental. This is the way we're going to integrate this application with that application. But to be honest, I'm preferring more an event sourcing route for that than just pure ETL. I'm a little bit reluctant to put transformations and stuff in the database directly.
It can be really nice, but there are certain scenarios where it's almost magical to see that. The problem is that it's not in your face. It's something that like schema script in SQL, it's something that happens, and you have to keep in mind that it's there and how do we version that and all those sort of things.
Yeah. It doesn't fit in with that workflow that you mentioned earlier, but spending most of the time in GitHub with pull requests.
Yeah. I think we are closing down on all of my questions. Do you have, when you're running RavenDB and you started from 4.1 or 4.0, so very early in the process, and now you're running the latest build. What was the process of running, updating while everything is still working?
Well, I think that was, back to what you're saying about your mom and the criteria for the house. Being able to upgrade without disruption was one of our key pain points. Like, we were scared to touch a cluster or take a node out of it. So that just had to work. And we've made good in actually using that feature, I think. The major upgrade to 5 took a little bit of planning, but ever since then, I think we've been within a week or two of every minor release that's come out. And that's been made possible by us having some automated tests in the staging environment just to, prove that there's nothing drastically wrong. And then being able to take a node at a time in our production environment, run it, upgrade it, stabilize it, and then move on to the next node without any disruption to the application or performance. That's not something we've ever been able to do before. And I can't say there's much aside from our own Kubernetes applications that we're able to upgrade with that kind of efficiency on it.
I can tell you from my perspective, the amount of work and complexity that it takes to make sure that this happens is a lot, like a lot to make sure that this happens. And we get into really interesting discussion. Do we actually need to support this really strange scenario? And we have users who are changing one node in the cluster and leave it for a month. Yeah. Just let's see. And then they replace another one. And I'm not sure if you will, but if you have a cluster that has multiple versions, then the cluster version would be the version of the majority of the nodes. Mm. So sometimes they replace one and then they wait and then they replace the second one. And now if they're running a 3-node cluster, then they shifted the cluster version to a new one. So that changes the behavior, and it makes for interesting system. But yeah. So while running RavenDB, we talk about, okay, this is good, this is good. What were the things that were surprising, both good and bad? That's interesting.
I think surprising. I know there's work going on at the moment, but we've seen it caught us out a few times on certain types of queries, like large date range queries and things like that. It just wasn't intuitive the way that particular thing manifested itself in terms of its performance profile. In terms of good things, certainly like the ability to debug, see traffic watch, see the thread, what's going on under the skin, like the studios stuff has certainly been a great help, as has whether it's our own homegrown version of Telegraph that queries the debug endpoints or the official one. That kind of stuff is incredibly useful just to correlate across applications, and that's been a really refreshing thing to see insight under the skin. I think just the ease of upgrading versions has been a pleasant surprise, but I perfectly appreciate how complex that can be for you with the multiple customers, for sure. But certainly it's been a boon for us on that side.
Okay. Let's see. I think I have few things. So is there anything else that you want to talk about? Stuff that we haven't talked about, things that deserve a mention?
I think there's certainly an advantage to RavenDB over its peers in terms of the approach it's taking, the amount of investment you put into the studio, the safe by default. That makes the technology easy to adopt. I think the roles of DBA or a full stack DBA are maybe underrepresented a little bit in all organizations. That's something that I'd love to see a little bit more focus on, either from you as the vendor, tailoring training around that sort of deep role, like, or us as organizations that we should have as a best practice. I think that role is key to adoption and is key to actually resilience and performance side of it. So that's maybe something to consider more formally. Other than that, yeah, I think RavenDB's got a certain growing feature set, and that's a good thing and a bad thing. It's more things to support, and maybe moves away from its original mission a little bit. But I've loved everything that's sort of gone in there for a good reason at the moment. I think that's really good.
Thank you. About the full stack DBA, the key issue here is not so much the training or given the insight into what's going on. That's both something that we do, and with the telemetry that we expose is something that I really care about. I think that the issue is that you have to be able to translate the technical terms into the business and be familiar enough with what is the business requirement, how it goes, to be able to say, okay, this is how we can do that. It used to be the case that the DBAs will, you were 10, 15 years in the company, and you were plugged into all of the databases, so you knew everything. And in many cases, the role was not just as the person who is in charge of the database, but also the person who is in charge of knowledge keeping, and this is how we do things, and this is why we do them. And I find that the rate that we're adding features and complexity in applications, it becomes a lot harder. One of the key drivers for many of the features that you talked about, like the telemetry, the traffic watch, things like that, were created for a very simple observation, and that's in many applications, in many organizations, you have a developer, and he comes and he builds a system, and then it runs. And then there is minimal maintenance, or it just, it's somewhere in the closet or some cloud servers, and no one really pays attention because it's working. And I remember at one point I was looking for a school for my daughter, and there was a parents' night, and I'm sitting there, and my phone is ringing. And this is an emergency support call. The entire application is down, and I'm talking to some guy. I think that he was the on-call engineer for the organization. He has never even heard about Raven, didn't know that it existed. I had to walk him through finding out where the server was from the configuration of the system. And the key issue there was something around after 3 years in production, they had a conflict because of a network error that happened 2 days ago. And now that conflict meant that when they're trying to load the main page of the application, RavenDB would send an error, hey, this is conflicted document. And you're expected to catch it and handle that. And the developer that wrote it never did that. And the developer that wrote it was long gone from this company, and there was no knowledge about what's going on. And that leaves me and the support team at an interesting position where we actually have to do archaeology. I don't know. I don't have a better term for that. In order to figure out what was the problem, was sometimes against the wishes of the organization, because I just wanted it to be fixed, but I don't even know what fixing that means. I can solve the problem of, you load the page, there is an error, we can just move that document aside. But in actually to solve the actual issue is, okay, now I need the business, now I need to be able to, what does this JSON document mean?
Yeah, I think going back to that point, maybe I'm doing it a disservice by saying it needs a full stack DBA. It needs the architect or principal developer to be curious about the technology, to do that archaeology for you. They often don't have the time to do it, but they also just don't have the curiosity to do it sometimes. And I think RavenDB is a good example of something that's very open, very approachable to build that curiosity about and get that skill set ingrained in an organization, especially throughout the onboarding process. It's something I've tried to encourage both on the operations side and on the development side. Is, hey, do your own exploratory test and try and break it, see how it behaves, and you'll learn from that. You'll gain knowledge from that. That'll be useful someday on this way.
So speaking about curiosity, RavenDB is an open source project, and at the same time, we treat it as if it wasn't. I mean, we don't typically ask you, hey, send me a patch for that. We say, okay, we will go and add this feature to the queue, and you'll get it in typically a few weeks to a few months. But you mentioned that you went in and looked at the code to understand what's going on. Can you tell me what you found, things that, oh, this is interesting, it works this way, or basically, why did you go there and what did you find in the code base?
I think the first place where we started was the debug endpoints because they weren't really in the documentation or discoverable. And I kept noticing once in a while your team using those. Okay, I'm going to write that down. I'm going to check it out myself just to see what's behind it, where it's pulling its information from. And those debug endpoints really give a good starting point into the internals of what's going on. And from that, we built our own sort of Telegraph plugin, and I think eventually that got took over by your team and stuff. But things like that entry point into seeing the debug endpoints that your team built for themselves to diagnose issues was a good introduction from that. And then from then on, we got to explore the client a little bit, like how the request pipeline works. I wanted to understand to see from my own just playing around is how hard would it be to add a gRPC endpoint in addition to your REST endpoint in there, just to see the whole pipeline? Or where could I plug in additional logging so I could enhance my own telemetry from the client side of things? Could we extract the query timings from the client and put them into our own Grafana, for example? So I have a bit of a passion background for the sort of observability side, and the debug endpoints were my first sort of foray into that. The rest of the code, we've dived in a little bit into serialization or the request pipeline, but haven't got into the deeper transactional or querying side of it. Lucene, I'm a little bit of an idiot when it comes to understanding Lucene, so fair play to you guys for understanding that side of it.
Me too. Here's the funny thing. I've been working with Lucene for, I think, 17 years now. More than that, some ridiculous amount of time, and I have a pretty good grasp of how it works, and it still managed to surprise me in its idiosyncrasies. There are many. At one point, I caught one of our developers looking at the serialization code to the internal binary format that you use inside of RavenDB, and I was like, what are you doing there? And my concern wasn't so much that he was looking into this code, is that don't tell me there is a bug here. That's sort of things that I have to meditate for 15 minutes before I go look at the code. There's a lot going on there.
Yeah, for sure.
Okay. Trevor, thank you so much for doing this. I found it incredibly insightful, and I hope that the watcher as well. For the people in the audience, do you have any questions, stuff you would like to raise at this point? And while we're waiting for any of them to raise their hand or put something on the chat, I think that the fact that we've been working together and you've been using RavenDB for such a long time has been incredibly rewarding for us as well, because I would have never thought that the manner in which you put the database to use would be I have blinders about how to use the database because I know how it works from the inside, so I use it in the appropriate manner. Then people come and do, oh yeah, that makes sense. And some of those changes, you mentioned the data queries, and we have gone through multiple rounds of optimizing that, and the performance impact to all of our users has been quite amazing. And we have questions now from David Nicolo. I hope I'm pronouncing that properly. He's asking, you talked about full stack unit tests. Do you use single server or cluster, or just spin a new database per test inside and destroy it after? Or do you spin a new embedded instance of the server for each one?
So David, thanks for the question. Full stack unit tests, there's no server or cluster involved. I can run that unit test on my local machine. It spins up the embedded version of RavenDB, which is an ethereal instance. Make sure the indexes and databases deployed in the test setup. That happens within milliseconds, and then runs the suite of unit tests. So no external interface. And again, my criteria for unit tests, including full stack unit tests, is they must run fast. They must run with no setup required, no external cluster or database, and they must produce repeatable and informative results. And by having the embedded version of it, just like, I guess, an in-memory version of SQLite, you can do that very fast with no external configuration or setup.
To expand on that, David, I assume that, by the way, you're using the test driver, right?
Yes.
Yeah, so RavenDB has a package called Raven Test Driver, and it's meant specifically for that scenario, for testing this properly. And the interesting in this regard is that the RavenDB isn't running as part of your process. You can run the test driver when you're writing JVM code. And that means that you can stop in the middle of the test and inspect the state of the database. And RavenDB would spawn a new process for you for the server process, manage all of the database creation, everything. Every test gets its own database. And the whole thing is basically meant to ensure that you have the good unit testing story without really having to think about that. We have another question now from Dario Rigolin. Did you compare data compression, ZSCD, or MongoDB with RavenDB? Any overhead on storage compression in RavenDB?
So we did not compare any compression side of it. We don't actually use compression because on our storage layer we have compression under that layer, so we're getting the benefit of that. Didn't want to add extra on top of it. So we're not explicitly compressing any of our collections, although I know we're benefiting from some of the new compression across the replication and things like that. The only compression that we've done is actually at our application layer. Like I said, encoding GUID slightly differently resulted in a fairly big gain on the data size. We don't use ZFS as a file system. We're on pure storage as our storage layer, and then locally NVMe. But I think most of our databases are under about 100, 200 gigabytes in size. It's not that important for us. Our biggest database is pushing a terabyte in size, and it is important to us. But we haven't, like, to answer your question, we haven't experienced the compression side and if it'll be a benefit or not. It might be an experiment I'll run someday, though.
One of the issues with terabyte databases is that running experiments on them takes a while. And if you want to do something like that, you can actually test this, because we made the dataset that we use for simulating Kobo scenarios public. And I think that we done that, and if I remember properly, we are something at 60% disk saving from the compression. There is benefits and disadvantages to that, because on one hand, you have to spend more CPU time to read the documents. On the other hand, because the documents are so much smaller, you pay a lot less on the disk. We actually have several benchmarks where this is actually cheaper in terms of overall performance to go with the compression, because in generally the disk cost is much higher than the CPU utilization.
Yeah, I agree with that. For us, where we've spent our optimization on our servers has been on moving from the SAN to NVMe and upgrading the amount of RAM available so that the working set of the database mostly is sitting in RAM. So I would assume compression might also help with that, given that there's more documents on the page and things like that. The measurement that we do on that is, like, we obviously have the latency times of specific requests, but we also track the IO wait time of the Linux kernel, like the CPU time, and then we have how much of that CPU time is actually waiting on IO. And that'll be, if I do experiment like that, that'll be one of the metrics I'll watch.
Okay, I think that's it. Thank you everyone for showing up, and Trevor, thank you so much for doing this. It's
No
wonderful.
problem.
Thank you.
Thank you very much for having me.
Goodbye.
Take care, everybody.